Yeah. Hi, everyone.
Good morning.
Good
Good
morning.
morning, Dr. Shanta and Dr. Gautam. I am Deepthi Verma from Maths Department, and I welcome both of you on behalf of DPS Bangalore East.
Yeah.
Thank you.
Hi. Hi. Yeah. So before we start, I just wanted to check that the students
Uh,
here are from 11th and 12th standard. Is that right?
yes, ma'am. There are more students from 11th and 12th standard whose
Okay.
videos and audios are off for the time being,
Okay.
but eventually, as you start interacting, they will turn on their
Okay.
audio and video.
Yeah. Okay.
So we will just
Sorry, I lost what you were saying. Shall I start?
Ma'am, we'll have a formal beginning and we'll go live right now. So you all of you will be able to see the top red dot.
Mm-hmm.
And as you see that, you'll realize that we've gone live. Our moderators will be initiating and then they will pass it over to you.
Okay.
Okay, so are you ready to everyone? Can we begin the program? We will start with showing the poster on our screen. Can we have the poster on the screen and then we'll all mute ourselves and also turn our videos off. Only the guests and the host can keep their videos on.
Sorry, sorry. After the introduction of the poster, could we allow
Yes.
students to unmute themselves and
Sure,
respond to
sure. Yes,
questions?
yes,
Yeah,
definitely. As you ask questions, we are going to
sure,
allow
sure.
students.
Yeah.
Thank you so much. Okay, ma'am, can we share the poster right now?
Good morning, ladies and gentlemen, distinguished guests, and esteemed viewers. I, Trinka Sarkar,
And I, Swati Srivastava.
as moderators, extend a very warm welcome to all of you to this engaging talk show, Power Hour Season 3, Episode 3.
Albert Einstein has said, pure mathematics is, in its way, the poetry of logical ideas. And in the next hour, we shall be presenting you just the same. This talk show promises to captivate your minds and stir your souls. We believe that the power of dialogue and the exchange of ideas can truly shape the world around us. So, without further ado, let the journey begin. Sit back, relax, and prepare to be enthralled as we embark on this remarkable talk show filled with wisdom, creativity, and the magic of meaningful conversations.
Our first guest of honor is Shanta Bhushan. She holds a PhD from IIT Bombay and was a DST Fellow at IISER Pune. Her academic work has included research on Riemannian manifolds whose geodesics are all periodic, as well as studies in knot theory to understand protein backbones. She has taught mathematics at Flame University, Pune. Her work with NGO Kalpavriksh on issues of biodiversity conservation and community-based conservation speaks a lot about her varied interests. She is a faculty in the School of Arts and Sciences, Azim Premji University. Ma'am's current research interests lie in strengthening math education at the school and college levels. She is presently engaged in creating resources for tactile and visual learners based on crafts such as crochet, knitting, weaving, and origami. to explore and experientially teach complex mathematical concepts. A very warm welcome to you, ma'am.
Thank you. Thank you.
Our second guest is Dr. Gautam Dayal. Sir has his doctoral degree from Chennai Mathematical Institute in cohomology of algebraic varieties. He has been actively involved in teaching school children from various backgrounds, ranging from underprivileged children to students at an international level. This kindled his interest in how children learn, and especially the role of play and learning by doing. Prior to moving to Azim Premji University, he was a faculty member of Srishti Institute for Art, Design and Technology for many years. Here, he taught courses in mathematics and computation in design, design in education, and experimental media. He is currently a faculty at Azim Premji University and is teaching design for communities. A very warm welcome to you, sir.
Thanks.
Educational games have always made learning more interactive. It helps students to grasp challenging concepts, strengthen their mathematical thinking, and problem-solving skills. Now, I would like to invite Dr. Shanta to take us on an exciting journey into the magical world of mathematical strategic games. Over to you, Dr. Shanta.
Thank you, Swati and Trinka ma'am. And I would like to thank DPS for organizing this wonderful interactive session. So a little bit I would like to add to what you said, ma'am, is that the math classroom, right, is generally perceived as something that is scary. Many people are afraid, anxious, and dislike mathematics. And the people who, so this is the general feeling about mathematics. And there's a lot of research on this of what causes this kind of fear and anxiety in the math classroom. So one of the possible reasons could be that when in a classroom, if students are told something and they're asked to apply it, and over and over, there is this feeling that students get that in the maths classroom, I have to be told what is to be done, and then I will follow. So the teacher will say, okay, here is how you solve quadratic equations, and then I know the formula, I'll plug it in, and all I have to do is make sure I don't get the decimal places wrong. So there is a lot of this discomfort, anxiety in the classroom. So for me as a teacher at the undergraduate level, what is very important is how can we change this? So I think for all the Gautam and myself and the team here is that how when students come to us in the first semester, how can we get students to be active learners? So this is our main goal. And of course, Professor Gautam will add on in his session about his ideas and his experiences. Okay, so Swati ma'am, you said something about dialogue, right? So we think of mathematics as a set of question and answers, and we go towards finding the truth. So that is what our classrooms are. And we adopt a pedagogy called inquiry-based learning, which we use. So what I thought would be, instead of me giving bhashan, I thought it will be fun for us if we could if in the next 15-20 minutes, I could give you a sample of the kinds of things that we do in class. So I would like all of you to take a strip of paper. Okay, so take a strip of paper like this. So I'll just give you 2 minutes, and we are going to do a very tiny activity, and I then want to get into the question answer mode, right? So tell me when you're ready. Take a piece of paper and cut it into a strip, not very thin, a kind of thing so that you can see the folds. and keep a pen ready so that you can mark the folds. Swati ma'am, if you can let me know when I should start. If the
Yes, ma'am. I think we all should be ready by now.
Okay, yeah, yeah. Okay, so here is a strip. Maybe I'll just stand so that yeah. Okay, can everybody see? I'm holding a strip of paper. Okay, so what we're going to do is just like we study biology, biology is the study of all living organisms, right? Whether they are plants or animals or virus, whatever. So in biology, we try to look at various organisms and we first start with observations. Okay, and we say that okay, we observe that some things move, some things don't move. Okay, so then we kind of say okay, there are two kinds of living organisms, one that move, one that don't move. Okay, so every discipline starts with observations, and similarly with maths. Okay, so what I'm going to ask you to do is take a strip of paper and make a fold here. So I one end of the strip, I have just, if you can see the dotted line, Swati ma'am, Trinka ma'am, you can see this dotted line. Yeah. So I want you to fold a mark, fold it, okay, and draw a dotted line so that you can see the fold. Okay. Yeah. So it can be any angle. Okay. I don't have a protractor and I am not interested in the exact value. Okay. So I started with some angle. Then after this fold, what I am going to do is take the top edge of this strip and fold it so that it now matches the fold that I had. Okay. So see, if you can see this black dot, so I've taken the top strip of the paper and I have folded it. Okay. And I get, when I get a fold, and then you can see this. Yeah. Okay. So what we are going to do next is we took the top and got this fold. Now I'm going to do the other way around. Okay. What I'm going to do is I'm going to take the bottom, okay, to create one more fold. What I'm doing is I'm taking the bottom edge and putting it here, okay, and in this process I'm making sure that the fold goes through this vertex, right? Okay, so I'm just going to bring up time. So in your paper, I'm just going to mark this a. Okay, can you see this? Yeah. So I started with this. Then I took the bottom edge, okay, and I folded it so that the first edge, the vertex, and this edge are in line. Okay. So I folded, I got this, then I opened it. Okay. Now I took the bottom edge and I did this. Okay. So now maybe you can take 2-3 minutes to do more of these. Okay. So now we did top, bottom. Now I'm going to do top again. Okay. So maybe you can also do the same thing. Okay. So make sure that when you're folding, the new vertex that was created, your fold goes through that and the top edge coincides with the edge that we had created. Okay. So I'm going to mark that again. Okay. So because I had taken the top edge, now I'm going to take the bottom edge, make sure it goes through this vertex. Okay. And then it goes through it. I fold it up like this. Okay. I've got, okay. Yeah. So, yeah. So maybe you can take 2-3 minutes and make folds like this and tell me what you observe.
So students, those who are ready with answers can raise their hands up. We will unmute you. You can answer.
Notice your face.
We are enabling chat also, so you can just respond in the chat, please.
I noticed the face only.
Sorry, I was not able to understand that. What did he say?
Ma'am, I think the child was not clear about the question. So can we repeat the question about?
Yeah, okay. So we keep making, so we notice that we get lot of triangles, right? Everybody has observed that we get triangles. So we started with one edge, then we folded the paper, the top edge, so that now the the vertex on top and the new edge. So this is how we created. Okay, we got, so we started with one edge, then we got one more edge. Then because we last time we took the top edge, now we take the bottom edge so that we create a new edge that goes through the previous one. This is the vertex that we had got. So we did this. Okay. Then when we unfold, we see that we get a new edge. Okay. So the first observation is that there are a whole lot of edges along the strip of the paper. There are vertices. So basically you can see triangles here. Yeah. Okay. So now what more do you notice? So we want to hear what are your observations. So different people would have started differently over here. Okay. So my initial angle, maybe somebody took a little less, little more. I don't know. Depending on what you took, I want you to maybe show the strip of paper and tell me your observations.
Children, please type your answer fast in the chat box.
Yeah, if you can show the strip of paper and the folds, and if you can mark it also, and then tell me what you observe.
Children, we are waiting.
Yeah. Okay. So I think this is a common experience because you don't know what the teacher is asking, right? What is your meaning of observation? Okay. So it may be small, it may be big, it may be spectacular, whatever you notice, right? So it may be as simple as that in my strip of paper, I got five triangles. Okay. In my strip of paper, I got only six triangles. Whatever it is, if we hear from everybody, then we want to see if there are patterns, right? If everybody is saying the same thing, then we'll start investigating that. Does that make sense? Yeah. Okay. Ma'am, I think Angshu has raised his or her hand.
তলাই লাগছে টনসু ବାପାଙ୍କର ଟ୍ୟାଗଟା ଟିକେ ଖୋଲିଦିଅ ସମାନରେ
Ma'am, I think Angshu has raised his or her hand. I don't know if others have raised.
Yeah, we will be just 2 minutes. Will be unmuted.
Yeah.
Yeah, so should I start my video as well?
Yes, you can show on the videos what you have prepared.
So, the strip here, it seems to me that all the triangles are the same, is what I'm observing.
Hmm. Okay. What do you mean by same?
Like, there'll be a similar size, the side lengths and the angles between them are also similar as well.
Okay. Okay.
So congruent.
So you're saying all triangles are congruent?
Yeah.
Okay. But very clearly in the strip that I am holding, can you see that the first two triangles are certainly not congruent?
Yeah. Apart from those, because if we extend the paper, then those will also start to form like the congruent
Okay.
triangles.
So when you
So
say
apart from the
congruent,
ends,
yeah. So when you say congruent, what do you mean? What is
so
your
all these
definition?
triangles in the middle,
Hmm.
all the big ones, right? All of these seem to be congruent to me,
Now, what is
is
your
what I'm
definition of
observing.
congruent?
When all the angles are the same and all the sides are the same length as well.
Okay. So one thing is, how do we check? Okay. So you noticed a pattern. Okay. So there are two things now. One is, can we check by paper folding? Okay. And
Right.
the other is to use our school geometry. Okay. There are two methods that we have. Hmm? So which method would you like to? So in mathematics, this is how we do mathematics. We observe something, we see the patterns, and then we kind of make a claim. Okay. We say that, yeah, so Anshu has made a claim that all triangles are congruent. Okay. So then the question is, if you want to convince Swati ma'am or Trinka ma'am that what you're saying is correct, how would you go about it?
So what I did here is I took all this, right?
Mm-hmm.
Putting these ends inside, I start folding it in, and we can see that it's just forming one big triangle here, right? It's the same size as all the other triangles that we drew,
Hmm.
and yeah, it seems to be just one triangle, right? All of these are folding very nicely into just this one.
Okay. So the question here is, it whatever you got depended on how we started, right? So
Hmm.
if you see, this was my starting angle. Okay.
Right.
What if I had taken some other angle? So suppose I had started with something like this. So you can see it's different. Originally, I started here. Okay, I stand up. Or my original angle was like this. But what if I had started like this? This is very close to 90. Okay.
Right.
But I still have got it. Okay.
Yeah, I think you still
So,
would have.
Max, Ayushman is asking, what is the question? So, the question is, what do you observe? Okay, so we are asking in the spirit of a scientist. The scientist is very curious. They do something and then they ask, hey, what's happening? And then when they understand, they guess, then they say, how do we explain it? So the explanation part is at the end. Okay. Yeah. So Aishman, I agree with you. We have triangles because of the way we construct it. So we have a rectangle. Okay. In this case, a finite rectangle. We started with folding one edge, okay, and then we got a series of triangles. Yeah, that is the first observation, that this method of folding gives us triangles. Okay, and because my paper is finite in length, I'm going to only get finitely many triangles. Okay, Ayushman is asking a very interesting question. He is asking, what should we calculate? Okay, so I am not telling you what to calculate. That is a big difference between an inquiry based classroom and a traditional classroom where I am not telling you to prove something or calculate something. I am saying we have done an experiment. What do you observe? What is your guess? Prove it to me. Right? It's very like, so if I show you a vegetable, then you will hold the vegetable in your hand and you will say, oh, this is pink in color. This is this. It's likely it's from this family, etc. Right? You observe and then you conclude. Hmm? So, in that spirit, I am not asking you to calculate. I am merely asking, what do you observe? Okay. Your first observation is uh, uh, the first observation was that there are all triangles, and then Angshu has said that all the triangles were congruent. Okay. Is there anybody else who agrees with Angshu that all the triangles are congruent? What should happen if all the triangles are congruent? All according to Angshu, all the three sides should be uh, identical in length and angles. Yeah. Okay. Is there anybody else who has observation similar to Angshu? You can put it in the chat box, or you can
Ma'am,
the
Anisha has an answer. Yeah.
yeah. Sorry, Ovi, can you please explain when you said there are parallel lines? Where do you observe parallel lines? There is a horizontal edge on top, a horizontal edge at the bottom. They are parallel, certainly. Because I took a strip of paper from a book, this is parallel to this. Okay. What else? Maybe I can name it A, B, C, D, E, G. Okay. You can see that I have named. Swati ma'am, is this clear? A, B, C, D, E, F.
Yes, ma'am. It's very, very
Yeah.
visible.
Yeah. Okay. So, which are the parallel edges and why do you think they are parallel? Okay, so the way in which we are, the session is about just what comes to your mind, share it. Okay, there is no grading, marking, nothing with this. Ovi, can you explain why you think there are parallel lines? Which are the parallel lines and why do you think they're parallel?
Ma'am, we have some very interesting answers in the chat.
Okay, I can only see, oh, 5 new. Sorry, I have not. Because they won't you mean intersect or they won't intersect. Okay, so now I'm assuming that you're talking about these edges. That is AB, uh, DE, EF. That's what I'm assuming because we started with these two as parallel. Okay. Yeah. Okay. So now we have two interesting observations. One is that all the triangles are congruent. Okay. And can you say anything more about it's congruent to what? What kind of properties does this triangle have? Is it a right angle triangle? Is it isosceles? Is it what is it? We know that there are, it's isosceles. Okay. So when you're saying isosceles, which two sides are you talking about? The dotted ones that we have created, I'm assuming. Yes. Okay. So you're assuming they're parallel. Okay. Angshu, can you tell a little bit more about what kind of triangle that you're getting?
Uh, for me, the triangle doesn't have any special properties other than the fact that they're all congruent. So, like mine, for example, is just Scalian, right?
Okay.
Let me just turn on my video here. This to me doesn't really seem like an isosceles triangle. The
Mm-hmm.
sides all seem to be different. So,
Mm.
yeah, the only thing I can see here is that all of these triangles, even the inverted ones, they're all
Mm-hmm.
congruent, is what it seems to be like to me. Because they're all overlapping on with each other perfectly. So this is the observation that I made. Like if we cut the extra parts out, then these should all overlap pretty well.
Okay, so we have two claims. So the word claim, I think you may not be familiar with because in school the word claim is not used. But if you feel like this is going to be true, okay, so then you say then you if you feel very strongly about something, you call it a claim, okay, and then if you prove it, you call it a theorem, right? So that is what Pythagoras must have done. He must have looked at a lot of right angled triangles, found that a squared plus b squared is c squared. Then he said, yeah, I feel that in any right angled triangle, a squared plus b squared is equal to c squared. Okay. And then somebody would have said, how do you know if I take some other right angled triangle? Are you sure that that will also have this property? At that point, Pythagoras would have said, okay, I am going to write a proof which really doesn't depend on the specific ABC that I take. So it's going to be true for every right angle triangle. Okay. Then somebody else would have asked, okay, suppose I ask the other way around. I have a triangle. I don't know what the angles are, but I know something about the sides. I know that the base squared plus the height squared is the hypotenuse squared. Do you think it will be a right angle triangle? Okay. So this is how the discipline of mathematics works. Okay. So coming back to this, okay. Now, if we want to prove these things, both these things, okay, one thing that we should remember is that in paper folding, one way to check whether two sides are same is I can put one edge on top of the other. Okay. So for example, I'm going to put this on top of this. Okay. I notice that they are not exactly, you can see a gap here, right? So if this edge is going to be exactly equal to the other edge, when I put it, it should coincide, but it's not coinciding. Okay. So the since we are running out of time, I just want to uh, wrap up this thing and say that finally what you will get is if you take a very long strip of paper, after 4 or 5 or 6 foldings, you will see that all the angles will be 60 degrees. Okay. So right now they are not 60 degrees. In fact, the first one is certainly not 60 degree. Okay. This angle is definitely more than 60. Okay. You can see that this triangle is certainly not a equilateral triangle. Okay. Not the second one, not the third one, but maybe if you do 4 or 5, this thing. So it seems like magic, right? I've done something, and after a few iterations means repeatedly doing it, I'm getting equilateral triangles. Okay. So since we are running out of time, so normally in our classrooms, we ask the class to come up with ideas on proving or disproving. So if Anshu has said something, I'll ask Anshu to prove it. And if Ayushman has said he observes isosceles, I'll ask him to prove. And then we will discuss which one is correct. Are both correct? Are neither of them correct? So we try to convince each other through logical steps, okay, which is what we call as a proof. Okay. So since we are running out of time, just one observation. 1 minute, I'll get the paper. So if you will see this, yeah, how is it? Yeah. So here, my starting edge was this. Okay. I don't know what this angle is. Okay. I'll call it something. It may be more than 60. It may be less than 60. Okay. So if I call this as 60 plus epsilon, okay, I don't know epsilon is positive, negative. Okay. And this is one thing that puts people off because we use a lot of Greek symbols, etc. So whatever you want to call it 60 plus something. You can call it X, A, B, epsilon, whatever. You notice that whatever this is, okay, this plus the two marked angles marked in red are going to be 180 degree. You all agree with me? because this is the top edge is a straight line. The sum of these three is going to be 180 degree. And because of the way we created the angle, we did this by folding. Okay. So the angles marked here on top in red, they are equal. Okay. So now I'm going to give names, right? So so I'm going to say we started with angle x0. We created two new angles x1. They are identical because we know that. That's how we created. Okay. So we get that x0 plus 2x1 is 180. Okay. So 2x1 plus x0 is 180. Can you then write x1? Ma'am, what time? Okay, so sorry, I just want to wrap up this and hand over to Professor Gautam. Okay, so then we look at the next one. Okay, so we will, this calculation will give us that x1 is uh, 60 minus epsilon by 2. If this was 60 plus epsilon, x1 is 60 minus epsilon by 2. Okay. Then x2 will be 60 plus epsilon by 4 and so on. Okay. Epsilon squared by 4, then epsilon cubed by 8, etc. So basically the error keeps reducing. Okay. And then we get a set of equilateral triangles. Okay. I think I will stop here, ma'am, because I'm running out. It's 10:30. So after Gautam sir's session is over, we can discuss this. I'll stop here.
Thank you so much, ma'am, for the wonderful presentation. It was a very, very interesting activity, a thought-provoking one. Let's now hand over to Trinka, ma'am, for the session.
Dr. Gautam, mathematics plays an important role in shaping design thinking, and it serves as a gateway to innovative career opportunities for the students. To take this discussion forward, I would like to request you to share your presentation. Uh,
Could you please make him the co-host? Yeah.
Gautam.
He had joined with the name of Gautam Narsinhataya.
Gautam sir, over to you.
Yeah, thanks. I was muted and I couldn't, and the chat was disabled, so I didn't know how to get in touch. Yeah. Thanks, Shanta, for that. And thanks, Tinka, Swati. So, yeah, before we start, I wanted to just say a few things so that you know why I'm doing this with you. So there was one of the questions had something about the math studio, and that's a space where we try and work with materials to play around. I like the word playing around. So it's not too serious to find out math things and play around with it. And when I was told that this is happening online, it's a little difficult to do, though Shanta managed very well, to do physical things on a computer and sort of show you. So I was thinking of what I should do. And there's a interesting programming. Everybody knows what I'm assuming people know what programming means, even if they don't do it. Right? You play around with a computer and you try and make things with it. So there's an interesting programming language that I've been trying out with students, other people, making things with it. And in a sense, you can approach it from a very mathematical sort of way of thinking, okay? Which is not to scare you, like Shanta said. It's math is not scary. Just think about it as playing around with stuff and see where it goes. Okay, so just to get a sense, how many of y'all have done some programming before? Programming any language, whatever language or whatever. Is there some way to see hands?
I think they are answering the chat box, sir.
Oh, okay. Okay, I'm going to see 3 people. Okay, not too many of you. That's strange. I thought it's a thing in. Yeah, my name is Gautama. So that's my middle name. Yeah. How many of you all have done some programming before? Either, I think people nowadays do Python or Java and things like that. So you just say yes or yes if you have. And then just to give me a sense of. Okay, we're getting some people saying yes. Okay, so, okay, let me see if I can share my screen. Okay, let's just share the whole. Yeah. Is my screen visible?
Yes.
Yeah.
Yes.
Okay.
Yes.
Okay. So let's just start with a blank slate. Okay, so I'm sure many of you all have heard about a programming language called Java, and we're not going to do Java. Okay? But at some point when things started getting really, people sort of started writing big programs, people sort of got a little fed up, some people, and said that they just want to play with the computer. They don't want to write programs and do fancy things and sell them to people. Just want to like fool around, play around with it. And they came. So some people wrote this programming language under Java called processing. So it's a bit of a strange name, but that's the name of it. So it's called processing. You can find it on Google and you can download it. Before processing, it used to be called design by numbers. Okay? So it was just about playing with numbers and seeing what you get. And at some point, it became a larger project. Now it's quite a large project and it's just called processing. Sometimes it's called processing.js, which is a different version of it. They're all the same sort of things. Okay? So the way it works is that um, yeah, I'm assuming you can see my cursor. So you type things here, then you press this um, play button and it runs. Okay. And unfortunately, there are 1 or 2 things which you just have to take for granted, which I'm going to type out, and then we'll start playing around. Okay. So you have something called setup, which you put in this thing, and you have something called draw. Okay? So I'm hoping that after this bit of which I've typed over there, everything else is understandable because it's all basically math and English and talking about things and things like that. So the way this works is that I'm assuming people have seen how comics are made or flip books and things like that. No, so you have one page, like you have a person with a hand, and then the next page has the hand a little higher, then a little higher, then a little higher. And when you play them fast, it looks like the hand is doing this. Right? That's how comics are made. So that's the way you think about this. So often you just need to say how big uh, that what do you call it book is. So you just give it a size. You say I want the size to be say 400 and 400. Okay? So that says how big my book is, and on this book I'm going to draw. So if I just run this and see what happens, I just get a blank window, yeah, which is 400 by 400. And one thing you should know is that this top right corner is called 0, 0, and the x increases that way, and the y increases this way. That's for historical reasons. So what we learn in math, we have to translate in our heads, translate both in terms of um, like a language, as well as translate like in math, you have to add uh, half the this thing this way and half the this thing that way to move the center to the top point. Right? You move the center here and center here, so the center. That's a silly pun about translate, but it is what it is. Yeah. So how do I now? I try and draw things. So let's try and draw something simple on it. So shall I say we draw an ellipse, and I want the ellipse in the center of the screen. So I have to say where the ellipse is. Right? So the screen, remember, or not screen, the window was 400 by 400. So the center will be 200 to the left. So that x is 200 and y is 200. And I want it to be a small ellipse. So let's say not an ellipse, even a circle, which means um, that I just uh, say it's 10 this way and 10 that. So let's just run this and see what happens. Yeah. So there's a circle which is 200 this way and 200 down. So x is 200 that way and y is 200 this way. And the size of the circle is 10 by 10. I mean, and the fact that I've called it an ellipse might make you curious. So the x and the y needn't be the same in uh, the axes needn't be the same. So if I were to make it, let's make it 10 and 55 and run it, I get something like this. Okay? So this is, so now you can play over here. Like instead of having a piece of paper and trying to draw on it, you can try and draw by giving it commands and it's drawing things. So I said, remember that it's like a flip book. But so far we've just seen one thing and it's been nice to see an ellipse. I mean, makes us all happy to see an ellipse, but it only makes us that happy, and then we think we're a little bored. So we need to do something more about it, right? So the way processing works is that it sets it up, and then this is sometimes called a draw loop. A loop means something that repeats again and again and again and again. So what you're seeing here is you're seeing it many times, I think 60 times a second or so, but every time it's drawing the same thing. So if it's my flip book and I flip the pages, oh, I should show my, and I flip the pages, then it's sort of, every page has just an ellipse on it and it's a little boring. So let's try and make the ellipse change a little bit. Yeah. So for example, I could try and make the ellipse, what can I do to an ellipse? I can try and make it, um, say it's small, and I can try and expand it, right? So what that means is that this number over here, 10, when it's small, it's 10. When it's 20, it's that way. When it's 30, it's that. When it's 40, 50, 60. So this number is what's called a parameter. A parameter is something which is like an input. If you remember your function you did long back, this function called ellipse, the inputs are the x coordinate, y coordinate, how big the x-axis is, and how big the y-axis. And what's the output? The output is the drawing the ellipse and giving it. So let's try and change some of this. Can I change this to 20? It's got a little thicker. 30. It's got a little thicker. 40. It's got a little thicker. And this is really boring for both you and me because I'm sitting and typing things and you're watching and I'm making 10, 20, 30. So it would be nice to have it happening automatically. So to see what it would look like if things got bigger and bigger. So I want to make this a number, like a variable. In math, we call them variables, right? So I want to make this some number called t, and I want to give t different values. So I need to tell the programming language all this stuff. So I need to say that I want a number. So here I have to say I want a number. And the number is a integer. Integers, you all know, I'm assuming. It's a counting number. 1, 2, 3. I'll 0 and -1 and -2. But I'll say I want an integer. The name of the integer is t. And I want it to be 0. Shall we do that? And let's see this. What happens? So it's drawing me an ellipse, which is this side, but t was 0. So it's drawing me just a line because it doesn't have any, the axis is 0, right? Now let's try and make it a bit bigger. So remember that I'm flipping a book. On the first page, I want it to be 0. On the second page, I want it to be maybe a little thicker, maybe 1. On the second page, I want it to be 2, and then 3, and then 4, and then 5. So what I'll do is let t be equal to t plus 1. And this is really bad math because t is never equal to t plus 1, right? I mean, so this is not to be interpreted that way. There are two ways of thinking about equal to. One is to say that these two things are equal. The other is to say, make this equal to this. And that's the sense we mean it by. So this is what's called, and I'll just write this, assignment. So I'm assigning t to become t plus 1. I'm not saying they're equal. And this is really unfortunate. Some programming languages, you write it like t colon equal to. This doesn't do that. It just tries to confuse you. And we'll get confused a little bit sometimes. But here we mean that it's an assignment. And when I write this over there, after those 2 slashes, it means it's just a note for you and me to sort of. So let's run this. So there, it's happening and it's getting bigger and bigger. And at some point, you won't be able to see it. Right? So, okay, so maybe I should ask if there are any questions at this point before we go on. How do I check if there are questions? Yes. Yeah, okay, if you have any questions, I'm not quite sure how I see your chat. I've lost it. Um,
Children, you can write your questions in the chat box.
no, we're okay. I can't see the question. I can't see the chat box. So, Ms. Tinka, if there are questions.
Yeah, 1 minute.
I don't know why Zoom has lost. Okay.
Sir, chat box is enabled. You are not able to see it?
Okay, now it's come from, yeah.
Yeah, yeah.
Okay, yeah. Okay, no questions? Okay, yeah.
Yeah, children, if you have any queries, please you can write it the chat box.
No? Okay. I'll assume there are none. Hopefully, if there are, ask. I mean, I don't know how you'll ask. Okay, I can put this side somewhere. Oops. Okay, I'll open this. Yeah? Okay. Okay, so this is one way where we're seeing um, numbers starting to be used to do to make things on the screen, right? Uh, there are two or three other small things like this that I thought I would sort of do, and let's see how it goes. Okay. One thing is that y'all we use a computer nowadays, and usually it's really nicely packaged, and it comes, and people don't need to know anything about what goes on behind numbers and how it happens and things like that. Right? It's all sort of it's all there. So, but this is just like a starting point of where numbers have sort of are used as parameters to go to other things. And this is where things like functions become really important, because you can take a number, make another number out of that, and feed that um, into the size of an ellipse, for example. But let's see other sort of things. Let's make a simple one, which just makes a circle move from the left to the right, and then move back and move forward and move back and move forward. Okay, so again, let's start with an ellipse and make a really small ellipse. So, and we'll put it at 200, 200, and 10 is the size of that circle. It's a circle ellipse. Yeah, it starts over there. And I want it to move a bit. So remember, how do I move it? Move means I need to change where it is situated. So I have X and I have Y. And if I change either X or Y or both, where it is will change. So uh, let's put this as T. Right? T was here. We made a integer called T. And let's change the value of T. Let's say T is equal to T plus 1. Yes? Let's run it and see what happens. Okay, can you see the circle moving? Unfortunately, it's left a trail. And the reason it's left a trail is uh, partly to do with how it's set up. I need to, every time I change the flip book, I need to say, I want nothing on it. And then I draw it. So let's do that. And the way you erase everything on it is that you say, set the background to be some number. Uh, and we'll come to numbers in a little while. Just call it 100. So I make the background 100. I draw this ellipse. Then I increase the where it should be. Then it's a loop. So change, go to the next thing, rub it all out, and draw the ellipse in the next place, and keep going. And let's see what that looks like. So you've got a ellipse moving. I keep saying ellipse, it's a circle. And when it becomes too big, you can't see it, which we'll have to fix at some point. Suppose I want to move faster, what do I do? Maybe I just increase this, no? I take bigger steps. Each time I change the page, I jump more. So that went quite fast. I don't know if you saw that. Yeah. Yeah. So depending on how these numbers change, the ellipse changes, the position of the ellipse changes. Why position? Because T is in the position of the y coordinate. So the y coordinate where it is changing. Yeah. So I could do something different, and I could say this. What do you think will happen? It's probably going to move across the screen. Right? Yeah. So it moves across the screen. Okay, let's make this little small. Okay. Now, supposing I wanted this thing to bounce back and forth. So it's starting from 0, it's going to 400, and then from 400, it's going back down. So to do this, we need to do a little bit of logic about how it works. So I can have, if I want t to move this way, I do +1, +2, whatever, +5, +5, keep adding 5 every time. Remember, this is not, t is not equal to t + 5, so that would be a contradiction. T is assigned to t + 5, right? So, okay, I'm running out of time a little bit, but never mind. Okay, let's do one. Okay, so this is one way to move things, and let me jump and skip the rest of this. I'm sure you can figure it out, but let's do something where you don't use ellipses, right? So remember we talked about background being 100. How are colors thought of? Colors are normally thought of as either a grayscale, which is why it's 100, it's between 0 and 255, or it's thought of as red and green and blue. So I have 3 numbers. So if I have a color which looks like 0, 0, oops, 5, 50. Let's see what this looks like. This gives me this color. Okay, if I want a different sort of color, 200, it's a bright blue color. Actually, I'm colorblind, but I know it's bright. It's RGB. Okay. So what you can do now is that, remember we said these are colors, no? The redness, greenness, and blueness of it. I can take the greenness and I can start increasing it. So green is RG, which is green, and blue. So make this thing. Let's make the greenness, okay, T, even though I should have called it G, maybe, of green. Let's see what happens when I do this. Oh, it doesn't like this. So it's getting greener hues, right? And yeah, so now I can, just like I was moving something on the screen, I can think of my color as a 3-dimensional space. It's like a cube which goes from 0 to 255. All these numbers go up to 255 for whatever reason, because it's 2 parts. Right? So my color is now a space, and I can move in that space, and I can show different colors depending on where I move. So for example, if I take a curve, normally I visualize it as in 3 space as something moving, but I can now move in this space of color, which means my red, green, and blue will change according to some sort of thing. So for example, let's just do last thing, 255 minus t. So this is like it's moving from 0 is increasing and greenness is increasing and blueness is decreasing. And let's just see what happens. So in some ways that, okay, it's not as spectacular as it could be, which is because, yeah, it needs a little more work to happen. But maybe we should stop. So I will. Yeah. So sorry, that was a bit hurried at the end, and I hadn't quite managed to finish what I want to, but yeah. But you get a sense of it. A lot of things when you're trying to do stuff, you have to think in terms of numbers and functions and how it happens so that what you want, you can do what you want. So it's a language, but a little more than language. Yeah. Thank you, and I'll stop now.
Thank you for your wonderful presentation, sir. Design and math indeed go hand in hand.
Dr. Gautam, your efforts to support and teach children with limited access to resources are truly commendable. Which experience inspired you to take this path and make such a meaningful impact?
Oh. Yeah. Actually, I don't know. I mean, to be very honest, I think one started off not looking at people who have or don't have and things, but just seeing how people learn stuff. Of course, using a computer is something which lots of people can't do, and I mean, don't have access to, and you work with other things. But I think, in a sense, it's sort of people get put off by math. I think Shanta was talking about this. Like, math puts off maths in, but it's very used in everything. I mean, this is one example in computers, but everywhere where you're doing things, you are playing a game, you're probably thinking about how how you pass objects to other people so that you're doing lots of math in your head. I mean, how fast people are running, how fast they're doing things. And in a way, when you start thinking about math in that way, it's a nice way to sort of start people off, I think, um, to do things, whether it's paper folding and trying to make um, patterns with it, which is where that would have headed after a while, I think. Uh, those are sort of things which do it, yeah.
That was a very honest response, sir. It will definitely inspire our audience to take up more subjects like these.
My question is to you, Dr. Shanta.
You have an extensive career and motivating journey in the field of mathematics. Could you please share your most significant experience so that our audience can gain insight from your professional journey?
Okay, that's a very broad question. Um, I think two things stand out for me in my academic journey. One is a teacher who I had in my, so I did a 4-year program called BSc BL. This was in Regional College of, it used to be called RC, now it's called Regional Institute of Education, RIE. There are 4 RIEs, and the main program at RIEs is to produce teachers. So you have teacher education programs. So I had a teacher whose name was Professor Basti, and he taught us a course in what is called as analysis, and he used this inquiry based learning. And so we probably did 3 theorems in the whole course, but it kind of was mind blowing for me. It opened up something for me to think of, to try and understand what is mathematics and what is mathematics education. So that for me, I think, was a very significant point in my journey. So when I moved to APU, and I moved at a time when the program was just starting. So in fact, I was part of the group that designed the whole program. So one of the things that I felt we should make a change was that the pedagogy needs to be something that allows children to explore, to share their thoughts, to fight with each other about their thoughts. I am right, you are wrong, etc. Of course, in a nice way. I feel that this is something we don't give space for in the school for various reasons, like our classrooms are large, whatever, right? We have 50, 60, 70 people sometimes. So classrooms are small, we have 35-minute sessions, the vast syllabus, etc. So there are good reasons why this kind of active learning, doesn't find a place. But I also think that we should start changing. I mean, yes, we have constraints, but how can we do better? So, anyway, coming back to your question, this was one thing that really, has shaped my life, academic life. The second one was when I was a PhD student, I struggled with something called hyperbolic geometry. Okay. For me, it was just a bunch of formula. So somebody said ds squared by x squared plus y squared, something happens, it drew some diagrams. It didn't make any sense to me. And I felt very, I'm a student of geometry, I don't understand this, etc. Many years after I graduated, there was a famous mathematician in Cornell called Taimina, Dr. Taimina, Diana Taimina. She taught a course in hyperbolic geometry, and her journey is also interesting. So she had to teach hyperbolic geometry, and she comes from East Europe. So she had learned hyperbolic geometry as a course, and she said, it's still a bunch of formula for me. This is not how I want to tell my students. And something happened, and then she realized that the crochet that she was doing actually was giving her a hyperbolic plane. Okay. So just to give an example, that in school we learned that if I draw a line and I draw a point, take a point outside the line, I ask how many lines now I can draw through that point P. Okay. And the answer is there's only one line which is parallel to the given line. Okay. But on a hyperbolic plane, if I take a line, and line means, okay, that needs some explanation, but the equivalent of a line. And then there are infinitely many lines passing through this which are parallel, okay, which is mind boggling because we have grown up thinking that this is the only model. But then there's a situation where there are no lines parallel through the point, etc. So the takeaway for me was that crochet is a pathway to understanding geometry. Okay. So after that, slowly knowingly and unknowingly, I always find activities that can help us understand mathematical truths through hands, right? And this is something that for some people it is natural, for some people they prefer books and audios and videos, but there is a large set of students for whom if they do something with their hand, they understand mathematical truth, and currently our classrooms leave them out. So my focus has been how can we include them. So that is my, sorry, long answer to a short question. Yeah.
But it was really, nice to hear about it. Your dedication and insights are actually very motivating, ma'am. It's inspiring to hear how your experiences shaped your professional path.
Thank
Uh,
you.
now we begin our fun-filled rapid fire round. Two of our students are eagerly looking forward to the opportunity to ask these questions to you. Over to you,
Okay.
students.
Yes. Good morning, everyone. I am Vedant Nair, and welcome to the rapid fire round. We will be asking a set of quick questions to each guest. We will start the rapid fire round with Shanta, ma'am. Ma'am, are you ready?
Yeah. Sorry, but what is this? I have no idea what
I would.
this.
So let's begin. Ma'am, you have an innate interest in various art forms. What is the one art form that you would love to master?
Weaving.
Weaving. That is truly a very fascinating art form, ma'am. My next question: what was your dream job as a child?
Being a teacher.
That's so it worked out well.
Yes.
My final question: what is the one animal that you think represents your personality or character traits the most?
Okay. It's both cat and dog. I'm fond of both cats and dogs. So, yeah, all my classroom examples are with cats and dogs. Yeah.
Yes, ma'am.
Both
There,
of them.
there, there are a lot of good qualities you can take away from those animals.
Yeah.
Thank you, ma'am. That's all. Over to you, Sana.
Good morning, everyone. I'm Sana Ghoshrai, and now we'll have the rapid fire round for Gautam sir. Sir, are you ready?
Uh, yeah, as ready as I'm going to be, I think.
All right, let's start. My first question is, who has been your biggest role model or mentor?
Uh, that's difficult. I think it was my guide for my PhD. Name was Kapil Paranjpe. So I think it was.
That's great. Yeah, I'm sure you have a special relationship with them. Which hobby helps you to relax and stay inspired?
Uh, I do woodwork, but I'm not sure it's a hobby, but it's close. I mean, yeah, I do it because it's relaxing. No,
Yeah, I
actually, if
can.
it's all relaxing, I think it's cooking.
Yeah, I
Yeah,
can
I
see
think.
how that would suit you in your busy day-to-day life. Name one book that has influenced your career and thinking the most.
Oh, no, I can't think of a single book. I think of various books which are nice books. Just now I'm not reading, but looking at a book called Indra's Pearls. I think Shanta would know, and that's quite nice. But again, I wouldn't say it's influenced me like hugely, but it's got lots of ideas which uh, feel
That's
like one
great.
should take home.
Yeah. I'm sure the viewers will give it a read now. And finally, what is your favorite travel destination?
Going home.
Yeah, that's wonderful. Okay, and that concludes the rapid fire round. Thank you, Gautam sir and Shanta ma'am, for being so sportive. I hope you enjoyed it as much as we did.
Thank you. I think you're muted. You're
We
muted.
can't hear you, Swati.
But ma'am, you're on mute.
Sorry, miss. Sorry. Yeah. So, thanks you, dear students, for the power play round. As our show concludes, thanks to our esteemed guests for enlightening us today and for your time and patience. We would like to express our heartfelt gratitude to the management, our principal, Dr. Manila Carvalho, and Vice Principal, Ms. Preeti Sutta, for providing us with this platform. We would like to thank the organizing committee, Head of the Department of Mathematics, Ms. Sirisha Chittur, and Ms. Deepti Verma from Maths Department, Head of the Department of English, Ms. Sonali Roy and Ms. Yoni Dikshit from the English Department for their guidance and motivation. This program would not have been a success without the support of the Head of the Department Computer Science, Ms. Vikranti Ashtikar, and her technical support team, Ms. Pooja Ahuja and Ms. Shamana Anju Ansari. Last but not the least, thanks to all our viewers. You have been a wonderful audience. Have a great day ahead. Thank you.
Thank you.
Thank you.